Okay, this is question 9. Yet again, notice another algorithm. My goodness me, this paper is full of algorithms. Figure 7 shows a famous algorithm that calculates the largest whole number that can be divided into two given numbers without leaving a remainder. For example, given the two numbers 12 and 16, 4 is the largest whole number that divides into them both. Okay, so it's basically looking for the highest common factor, if you recognize that term from your maths lessons. Okay, so here's our algorithm. We've got line numbers in here. They're not included in the actual algorithm. They help us guide us through. And let's complete the trace table for this algorithm when the user enters 15 and then 39. In other words, this is 15 and this is 39, and that's what they've put in the table for us. So what does it say? It says while, and then this condition. We've got to test this condition. Is 15 not equal to 39? Yes, it is not equal to. So this is true because they're not equal. So we do execute this code here inside the while loop. And now we need to test this decision. If number 1 is greater than number 2, well, number 1 is 15, number 2 is 39. So number 1 is not greater than. So that's not true. So we won't go into here. Instead, we're going to go into the else statement. And we're going to now calculate number 2 to be number 2 minus number 1. So number 2 becomes, what number 2 is now? 39. Here, look. Minus number 1, 15. So we do 39 minus 15, which of course is 24. We're going to assign that to number 2. So this becomes 24. And then we're going to go back up to the top of the while loop up here now. So we're sitting back at the while loop with number 1 being 15 and number 2 being 24. So are they not equal? Yes, they are not equal. They're different. So we're now going to go into this while loop again. So if number 1 is greater than number 2, well, 15 is not greater than 24. So again, we're going to go into this else statement, and we're going to calculate number 2 being number 2, 24 minus 15, and 24 minus 15 is 9. So we're going to allocate number 2 to be 9. And then we're going to go back up to the start of the while loop again. So we're sitting on line 3 again now. Number 1 not equal to number 2. Well, 15 and 9, they are different, so this is true. So we're going to do this code here. If number 1 is greater than number 2, so is 15 greater than 9? Yes, 15 is greater than 9. So we're going to do this statement now. Number 1 is number 1 minus number 2. So number 1 is 15 becomes number 1, which is 15 minus 9. And 15 minus 9 is 6. So this now becomes 6. And then we're going to go down to the end of the while, back up here, and we're going to test this condition again. Are they different? Yes, they are different, because 6 and 9 are not the same value. So we're going to come inside here. Is number 1 greater than number 2? No, it isn't. It's less than. So we're going to do this else statement here. Number 2 becomes number 2 minus number 1. So number 2 is going to be 9 minus 6, which is 3. So this now becomes 3. And then we finish that now. So back up to the while loop again. And again, while number 1 not equal to number 2. Well, they are different again. So 6 and 3, they're different. So this is true. So therefore, we're going to go inside here again. If number 1 is greater than number 2, well, it is, because 6 is greater than 3. So number 1 becomes number 1 minus number 2. So number 1, which is 6 at the moment, becomes 6 minus 3. And 6 minus 3 is 3, and we assign that to number 1. Okay, so we're down here again, back up to the while loop, and now we test it again. Is number 1 not equal to number 2? Yes, they are actually equal. So this not equal is false, because number 1 is equal to number 2, not equal. So this will not be true anymore. This will be false, in which case we will not go inside the while loop and we finish. 9.2. State the line number from the algorithm in figure 7 where selection is first used. What is selection? Remember, selection is if statements, and that's line number 4 with this if statement here. Line 4. And the next bit is, actually I'm just going to, because I can't turn over the page quite as easily as you can, I'm going to take a screenshot of this again, and I'm going to put it over here to help, so we don't have to keep turning backwards and forwards. Right, so state the line number in figure 7 where iteration is first used. Well, iterations are while loops and for loops, or loops, and therefore that's going to be line 3. That's where the while loop takes place. How many lines in the algorithm use variable assignment? So assignment is where we've got this arrow. So that's 1, 2, 3, 4. 4 lines. A programmer wants to implement the algorithm in figure 7 in their code. Explain why it would be beneficial to implement this as a subroutine. Notice we've got 2 marks. We've got to make 2 points. So first things first is, at the moment, this is getting specific things from a user. So once we've got these specific values, number 1 and number 2, from the user, that's it. We can't really sort of change it. So it enables us to reuse the code. So enables the code to be reusable for different parameterized num1, num2 values. Okay, so you could sort of, in pseudocode, imagine subroutine, and we'd maybe call it highest common factor, and then we'd have num1 here, num2 here, and then instead of having these wouldn't be here anymore. We would just say while, and then etc. Okay, and then the num1 and num2 are passed in from arguments as these parameters. So it also makes it easier to test. So there's various other answers here. Easier to test. Reuse is the most important one. It also perhaps becomes easier to maintain. So maintaining, or it could be used by other programmers. A reusable function for other programmers. So there's some of the answers that you should give for that.